What is the range of the data type bytes in Java? Option A -128 to 127. Option B -32,768 to 32,767. Option C 0 to 255. Option D -2147 4836 48 to 2147 4836 47. Okay, let's understand all these options one by one and find out the correct one. Okay, let's first understand the question. Question is asking about byte in Java, a primitive data type. In Java, data types have fixed sizes and ranges regardless of their platform or OS operating system. Let me tell you facts about the byte in Java. First, size 8 bits, which is equal to 1 byte, and byte is signed. Yes, Java does not have an unsigned byte. And storage format 2's complement. What 2's complement means in simple terms? Let me tell you. The problem was computer need a way to represent negative numbers using only zeros and ones. If we just used a sign bit like +5, let me take the example for 2's complement. Let me change the color. Okay, +5 in binary is 000000101, and -5 in binary is 100000101. Math operations become messy if you use this one. So instead, most systems including Java use 2's complement. With the help of 2's complement, what we do, actually let me take one example how we can use 2's complement. The idea behind the 2's complement, just let me explain. The idea of 2's complement is to represent a negative number in binary. How we do that? Just let me take one example like the first one. Let me write it again. This is number 5 and in binary 000000101. Take the binary of its absolute value. We have taken the binary of its absolute value and invert all bits, change 0 to 1, change 0 to 1 and 1 to 0. Okay, let's do that. Change 0 to 1 and 1 to 0. So the same bits is going to change. It would be 1 1 1 1 1 0 1 0, and then we need to add 1 to the result. Let me just add the 1 and you will get 1 1 0 1 1 1 1 1. So -5 is stored as 1 1 1 1 0 1 1 in 8 bit. Why it's a smart way to do that? Just let me tell you. Addition or subtraction just works without special rules. Like if you subtract -5 from +5, the final answer would be 0. And if you subtract the absolute values in binary, just let me change the color and let me show you. For +5, we have 0 0 0 0 0 1 0 1, and for minus 5 we have in binary we just calculated 1 1 1 1 1 0 1 1. When we add these two numbers, the final answer would be 0 0 0 0 0 0 0 0. Only one 0 exists, not 0 plus and not minus 0. So range is asymmetric. What it is saying, just let me tell you. Range is asymmetric. Why? For 8 bit. Okay, just let me tell you what is asymmetric range. What is asymmetric? Let me write it in more clear way. Asymmetric. Let me tell you what is symmetric range and what is asymmetric range. First, let me tell you the symmetric range. Symmetric range. If a number system had equal negative and positive limits, it would be symmetric. For example, range minus 127 to plus 127. This is symmetric around 0. This is symmetric around 0. Like 127 negative values and 127 positive values. And okay, let's talk about asymmetric range. Let me change the color. Yes. Asymmetric range for an 8-bit Java byte using 2's complement, the range is minus 128 to 127 in plus. You can notice here negative side goes one step further and the positive side only goes up to 127. So the counts are 128 negative values and 127 positive values. 1 0 is there. That is what we mean by asymmetric. The negative side has one extra values compared to the positive side. The reason is why? Because in 2's complement, the MSB most significant bit is the sign bit. Let me show you. Like 1 0 0 0 0 0 0 0 is equal to minus 128 is smallest, and 0 1 1 1 1 1 1 1 which is plus 127 which is largest. There is no way to represent plus 128 in 8 bits. So the range is uneven. The range is uneven. Let me summarize. Storage format is 2's complement. Let me summarize. 2's complement is method of representing signed integer in a binary where negative numbers are stored as the binary complements of their absolute value plus 1. For calculating the range, we have the formula. For minimum, we have minus 2 power n minus 1, and for maximum, we have 2 power n minus 1 minus 1, where n is the number of bits. Okay, let's apply the formula. What we are doing? We are applying the formula. Applying the formula to verify. Let me show you. For min calculation, let me change the color. Yes, for minimum value we have the formula here. Let me just use that formula. 2 power n value is for bytes has 8 bits. We know that 1 byte which is equal to 8 bits. So we take here, this is n. So 8 minus 1, yes, 2 power 8 minus 1 becomes minus 2 power 7. 2 power 7 is 128. This is the minimum value for byte. For maximum value, let me just calculate. For max, we have minus 2, and here since byte has 8 bits, n is equal to 8 again. So 8 minus 1 and minus 1 equal to, it becomes minus 2 power 7, 2 power 7 minus 1, which is going to, okay, here we do not have the minus. Yes, then we have 128 minus 1, which is 127. This is the maximum range and this is the minimum range for the byte data type. Okay, let's come back to the question. Now we clearly know which option is correct. Option A is correct. Minus 128 to 127. Why not B option? Okay, just let me check the other options too. Why not the other options? Okay, let's check option B. Minus 32,768 to 32,767. This is the range of a short data type. This is the range of short data type 16-bit. So that is why option B is wrong. Okay, let's check option C. 0 to 255. This is the range of unsigned byte. Not in Java, but like in C or C++. C or C++. Not in Java. So that is why option C is wrong. Okay, let's check option D. Option D is the range of int 32-bit. Option D is the range of int 32-bit. This is the range for that. So only one option is correct, that is option A. Let me write. Option A is correct. Okay, now we know which option is correct. But for the understanding, I'm just want to show you one example code so that you can imbibe the whole thing clearly. This is the example for that byte range. Here we have a class main, and then we have the main method, entry point of our Java program, and then we have system.out.println, which is printing byte minimum value, then concatenation, then we have byte.min value, and in another line we have system.out.println byte max value, then again concatenation, then byte.max underscore value. Byte.min value will show you the minimum value of byte data type. You can see here, once you run this code, you will get output as byte min value, which is equal to minus 128. And once you run this program, another output you will get as a max value, which is 127. In Java, byte.min underscore value and byte.max value are part of java.lang package which imported automatically for every program. In Java, you don't explicitly import byte or integer, string, math, etc. because they live in the java.lang package. Maybe sometimes we confuse who imports it. Let me tell you for that. The Java compiler, Java compiler, let me change the color. Yes, Java compiler does this automatically for you behind the scene. When you write this code, java.lang.package, which includes byte, integer, object, string, etc., is imported automatically by the Java compiler. For other packages like java.util.star, let me write java.util.star, like array list, scanner, etc. if you are using, you must import them manually. But for these values, you don't need to import java.lang.byte because the compiler will do automatically for you. Now I have shows you the quick way to verify in Java with the help of this program. Okay, let's come back to the question. In the question, okay, option D is wrong because it is a 32-bit integer range. Okay, option A is correct. Okay, that's all for this lecture. I'll see you in the next one.